I would like to talk for a little bit about how to teach science in a homeschool environment to all your children at once. Now, I'm going to give a little caveat to this. I think that you should think of your children as being 3 different levels. I think you should think of the early years, which those are the ones that they don't know yet how to read on their own. They wouldn't be able to comprehend a book if you handed it to them. So it might be children that are still learning how to read, but they wouldn't be able to completely understand. So around 4th or 5th grade, you see a shift, and understanding really opens up, and children comprehend what they're reading. They're not having to think about how to sound things out as often, but they're actually understanding what they're reading and interacting with it. So that would be the middle years, and that goes through about 8th grade. And then you have high school, and high school has to be its own individual thing here, because high school students often are asked on a transcript what science classes they've had, and this is especially important for those students that are going to be going off to college. So those 3 levels, you have a different thing that you have to concentrate on as you teach science, but you can still do it all together. I want to show you how to do that today. I also want to show you how you can use the Bible as your primary textbook. The Bible is not necessarily a science book, and I've heard this so many times. People will say, well, I don't really understand how you could use the Bible as your primary textbook for science. The Bible's not a science book. No, it is not a science book, but it recounts to us our Creator. And our Creator, first of all, has written down for us in the very beginning of Genesis how He created the world. And if we read it in the original language, Hebrew, it really opens up so much. But even more so, we have the eyewitness accounts of people who have lived all through time, and we notice something about creation. It's the same when Job and Abraham were alive as it is today. Now, I know there have been some variations, but overall, the way his creation works is the same. So when Job especially writes a lot in his poems about creation, or in the Psalms, the psalmists, the various ones, write about creation. Or in Genesis, we read about the first time that something was invented and how they went about it. Or we have to think to ourselves, how did they build that city? Or how did they ever get the technology to make that specific invention? As we look at the Bible, we can dive in and think, okay, how did that work? And another thing that is so fascinating about the Bible puts certain emphases on certain things in creation that is often different from how our local public school might do it. For instance, I find that astronomy is mentioned all throughout the Bible. It's as if He expects us to go outside at night and, wow, novel idea, and look up at the sky. And when we do, we will completely understand that there is a creator, a designer. Also, when we look at flowers or animals or the human body, we realize that there is a designer, that this didn't happen by chance. Having said that, from an evolutionary perspective, everything did happen by chance. It's all mutations, and it just happened, and you just happened, and after you, more people will just happen. And so it's an entirely different way of looking at science. Also from a local public school perspective, it's very humanistic, meaning man-centered. And so they're going to spend an awful lot of time on mankind and what we can invent and what we can do, machines and physics and so on. I'm not saying that's bad. I think it's really useful because we are supposed to take dominion over the earth and subdue it. But I think the more time we spend studying our Creator, the one whose image we're supposed to be in, then we have a better idea how to function in the world. And so I think in our science curriculum, we should spend time thinking about the things that He thinks about in about the same proportion, which is different than what a local public school would do. So that brings us to a couple issues. In our curriculum, we start at the beginning of Genesis 1, and we study verse by verse, word by word, oftentimes, what did the Father create? And then we move in through the rest of the Bible and talk about it, and we try to analyze everything in history so that it's we make sure that we can analyze scientists and say, did they do things according to the Bible, or did they do things their own way and not even acknowledge that there was a creator? And we can see a vast difference in the way that they came up with inventions and new technology and so on. So if we go verse by verse through the Bible, we're not going to have everything in neat and tidy buckets. It's not going to be just a year of biology and a year of chemistry and a year of physics, but we're going to intermix a little chemistry in with the biology and a little chemistry in with the physics and a lot of astronomy in with the physics. And it's just not as neat and tidy. It's neat and tidy from a theologian's perspective because we go verse by verse, but it's definitely not as neat and tidy from a how am I ever going to put this on a transcript and give my child a report card for science perspective. So we feel at Homeschooling Torah that from kindergarten or preschool, however soon you want to start science, until they're able to read and comprehend, which is, let's say, 4th grade for ease of today. We say that those kids really don't need to have science every single day. They don't need to be studying all of the vocabulary and knowing their definitions and all of the math behind it for sure. So we think for younger kids, we should have more of an emphasis on letting them go outside and play, being with the environment and interacting with the world around. Now, we do see children at very young ages interested in the world that God created. So for me, I feel like my children, it should be interest-led. If they're interested, as a friend of mine, her son is interested in vacuum cleaners. If he is interested in vacuum cleaners and wants to take them all apart and put them all together again and see how they work, then by all means, funnel that in. This is the time for interest-based learning. It is also the time to make sure our kids are playing, that they're building things, they're being constructive in their play, and it is also the time to make sure they are outside as often as possible, because outside is creation, and not just in the daytime. Take them outside at night. Help them to understand the biblical calendar by using the moon. I'll help them to notice sunrise and sunset. Help them to understand the stars and the constellations as they move throughout the year. This is all stuff you can do with young children. Now, I don't really have it as a schedule for that. In our curriculum, what we do is we have one day a week where your kids, you can get together with those younger ones, those early readers, and you can just talk about a science topic and bring them to the Bible, maybe help them do a little bit of a copy work from the Bible verse. And then the intention is that the rest of the week you can have simple discussions with your children and bring them back to that discussion that you were having. For instance, one of the very first things we talk about in our science curriculum is waves, sound waves, water waves, and so on. And we talk about how the Spirit of God hovered over the face of the waters right before he said, "Let there be light." And so we talk about those waves, and we go in the bathtub and we can make waves in the bathtub. Now that's the official science project for those young kids that the beginning of the week. But the rest of the week, my goodness, you can notice waves everywhere. You can notice waves as you pour their drink in their glass at lunchtime. Notice the waves as it swirls around. You can outside you can notice the laundry flapping in the wind and say, look at that, looks like a wave right there. Just as much as possible, bring it back to, and of course you can memorize the verse. And I like taking little ones to the library, helping them look at books. As much as possible, it's just very hands-on. You don't have to get much fancier than that, unless your child wants to. If their interest led into that, by all means do it. Now, once your kids get to about 4th or 5th grade and they're able to read and understand, it's a good time to start diving into some good science discussions. And in our home, we bring it down to every day. So this is how a week looks for us. We start every week with the vocabulary of the topic we're discussing. Now, the topics are chosen from Genesis chapter 1. So let's say we were talking about sound waves. We might learn all about the electromagnetic spectrum and all of the different kinds of waves that there are, from sound to light, microwaves, and ultraviolet, and so on. So with our children, we first need to define those things. What is a wave? What is the actual definition of a wave? What is the definition of a microwave? What is the definition of ultraviolet? On and on. We have these listed in the curriculum, so you don't have to think of them yourself. But this is when you're going to have to get out a dictionary. If you have a dictionary, a good one, I don't think like an elementary school dictionary, because it's not going to have these words. I'm thinking more of a high school or college level dictionary. Even though you're talking to a 4th grader, if you have a discussion, you can understand what the word means. And again, as I've said over and over, Discussion is the most important part of homeschooling. As you're talking to your children as you sit, as you walk, as you go along the way, as you lie down, as you rise up. I said too many of them. So you are having those discussions with your children. So the very first day, define the words so that you can all understand what is meant by it. Now, if you don't know what it means, then that's okay. You can learn along with your kids. The internet to me is invaluable. I have some trusty websites I go to, whether from dictionary.com or Wikipedia. It is okay at this very beginning to start with an encyclopedic or dictionary level. You don't have to know everything about it, but you're just understanding enough to be able to understand the jargon as you talk the rest of the week. Next, let's go to the Word of God. Let's dive in. Let's find out what the Hebrew for that word means. When it says he hovered, the Spirit of God hovered over the face of the waters, I'm thinking of so many words we could look up. We could look up Spirit. We could look up God. We could look up hovered, face, waters. I mean, those are all things we should know what the word is in Hebrew and what it means. And this is where I really love my Jeff Benner's Ancient Hebrew Lexicon, because he puts in every definition a concrete and an abstract. And the concrete definition of a word is something you can feel and touch, and that's great for kids. So then there's the abstract with all of the higher ideas, the philosophical ways of looking at something. So you can understand what spirit is, that it's just simply a breath. And when you have a breath come out, feel that. You do it right now. You can feel that on your hands. Why? What happened? What made it so that when I speak, it comes into my hands? So we're going to dive into the Word of God. We're going to find out what the Word of God says, and then we're going to use what we call the 6 serving men. These are going to help us to be scientific. The basis of science is to ask questions. The scientific method is we ask a question and then we think to ourselves, well, this is a possible explanation as to why I can feel something on my hand when I feel my breath. Okay, why would that be? So my first one is why. The 6 serving men are who, what, where, when, why, and how. And if I ask those for all of these questions, who can do that? If I put this in front of a lizard, am I going to feel anything? Why not? You know, you can just ask where. If I did this in the dark, upstairs, on the moon, all those places, would I still feel the breath on my hand? That's an interesting question. When? Would it be different in the winter than it is in the summer? You know, anyway, I could just keep going through all of these questions. Now, we have given you a lot of ideas already in the curriculum, but I guess I'm trying to say, go off script. It's okay. Ask questions. Really make it your own. Best of all, if you can tell stories, say to your kids, you know what? I remember when I was a child and I went out in the wintertime and I went on a window and it made all of this really cool ice pattern on the glass. And suddenly we brought that science down to our level. Or we can say, why can I warm up my hands in the winter when I breathe on them? What's the mechanism that makes that happen? So as much as possible, stories are fantastic. In the curriculum, we're also going to introduce you to famous scientists and tell you a little bit about their stories, because that also makes it come alive and a little bit more down to earth. Lastly, we're going to try to get hands-on with this. Now, you can't do this all the time. It's just not practical. But as much as possible, try to touch and feel and manipulate science, which is why with the little ones, we go into the bathroom and we make waves in the bathtub. And you can do that with the high school students too. No reason why they can't go in the bathtub and make waves in the tub. They'll probably love it. And you will make really strong impressions. But for our high school students, you might be able to take a microwave that no one's using anymore and take it apart and figure out what makes it work, what makes it shoot the microwaves inside of the machine. This is just some ideas, and there are many, many in the curriculum, so you don't have to come up with them all yourself. So one of the things then we have our children do is record what they have learned. This is incredibly important in science. I think if you didn't use notebooking in some of your other subjects, I would try very hard to do it in science. Why? Because the basis of the scientific method is recording our observations. We record them so that someone else could come along and see what we've done, see our process, and try to duplicate it. Why is that important? Because science is trying to search for truth. And truth, according to the Torah, is established on the testimony of 2 or 3 witnesses. So if you do something in science, if you say, every time I throw a washcloth into the bathtub, it makes a wave that's this big, someone else should be able to come into the bathtub with the same kind of washcloth and throw it into the same kind of tub and get the same kind of wave. And a third person would then be able to do it as well. So when we write down our observations in our notebook, step by step, this is what I did, and this is what happened, and this is what it looked like, someone else could duplicate that, and this is how we establish what scientific truth is. I wish I could impress on everyone that the most important part of science is the eyewitness account. That's the reason why evolution cannot be a scientific topic. No one saw it evolve. Now they can try to make experiments to make it happen and duplicate it, and in fact when they do that, they find out that it's even more likely that it was intelligently designed and made at one single moment in history. So the reason that but regardless of that, evolution or creation, we are only going on a theory, a story. We have one eyewitness account, and then we have Adam, who is the first man, and he has an eyewitness account, but no one was really there except for that. Outside of that, everything since then, we can have 2 or 3 witnesses. Ever since Adam and Eve were both created, now we can establish truth and what happened. And if the testimonies agree, then that is science. So in the scientific method, we ask a question, we think of possible reasons to answer the question that we asked, then we do an experiment to see what happens, and we write down our observations, and then, this is important, we do then experiment again and then write our observations down. Now in homeschool, a lot of times we're not actually experimenting. We're doing what is called a demonstration. We already know what's going to happen, but how do we know that? Well, because more than 2 or 3 witnesses have already done it. In fact, I think that's one of the biggest frustrations I have with science is when and this happens all the time, even on our curriculum, the materials will tell you to do step by step. This lab, I want you to make this step by step, mix this amount of baking soda and this amount of vinegar, and you do the whole experiment, and it doesn't happen like they said it would. And you're like, okay, that was not really exciting. Well, I don't know what happened. But that's how science is. Science has to be duplicatable. Is that a word? So making the notebooking pages with your children and having them learn to write down what they observed. Again, use those 6 serving men, who, what, when, where, why, and how, and have them learn to draw pictures, label, and take really good notes. So because of that, don't just stop by watching the demonstration or watching an experiment or going outside and taking a walk. Teach your children how to record what they saw and with their own eyes in a book. For our children, this can start very young. It doesn't have to be a high school student that's recording. You can teach your very young child to go outside when they find a pretty leaf to come inside and draw a picture of it and try to get it as accurate as possible. This is something that you seriously can start very early. Now, how do you do labs in a homeschool environment? Well, the kitchen is the easiest place, and the kitchen is important because in a laboratory, in a real scientific laboratory, you have to measure everything and you have to calculate. So if you have a kitchen scale where you can see weights, especially if they switch from English measurements to metric, that's going to be really useful in science. But you don't have to do a science experiment to get that. You can make sourdough bread to do it, or a cake, or anything in the kitchen that you're making. You can teach your children how to be very scientific about it. For instance, a lot of us, when we cook, we just throw a little bit of this and a little bit of that, and everyone says, that tasted great, how'd you make it? And we're like, I don't know, I just threw a little bit in. That's not a very scientific way of doing it. So for the sake of our children, we might sometimes teach them how to measure very accurately with a measuring spoon, how to weigh very accurately with a scale, and it's not very expensive to get a kitchen scale. We can teach them how to document, see what I said about notebooking? Document exactly what went into the recipe, And then have a sibling come in and make the exact same thing. Okay, you can watch each other to be sure that it's accurate and see if you get the same result. If you don't get the same result, you're going to ask yourself questions like, is it raining today and it was dry yesterday? Is it cold today and it was hot the last time we did it? Those are some things that can definitely make a difference. Even the altitude at which your house is. If you did this in Georgia and then went up into the Rocky Mountains and made the same recipe, you would definitely get a different result. And that's a very scientific way of looking at the kitchen. Learning how to calculate a recipe in metric and in English, and how to double a recipe, triple a recipe, and so on. Those are important and easy skills. Another way you can get some laboratory practice in your kitchen would be maybe to make your own supplements. Figure out how much of that turmeric would I put in and what filler I could, let's see, I could buy some dextrose from Amazon, and I could get a little pill holder and put all the 25 pills in it, and I'd have to put on a kitchen scale exactly how much turmeric I want in one pill and multiply that out times 25. And this is tiny little weights because they're very small. And you'd have to learn how to very accurately mix the dextrose and the turmeric all together, and then divide it by putting it over and scooping it in and weighing it down. And now let's weigh this turmeric pill and do the math and see if we actually got what we thought inside of it. And like there's no end to what you could do in the kitchen. Some people ask, what do we do about dissecting, say, a frog? That's a very common biology experiment, or taking apart a worm, or making a big board with bugs on it and putting the pins through and labeling each one. And I have to ask myself, I know that these are unclean animals, but some scientists have to observe the world around them, and in the process of doing it, they're going to touch an unclean thing, and they're going to become unclean, and they're going to need to take a bath and wash their clothes. I suppose if I had to do that every single day for my job, I wouldn't like it very much. But for the sake of science, once in a while, it's probably okay. You could use gloves and never touch the unclean thing, and teach your children how to very carefully take the gloves off and dispose of them without touching anything in your house. You could also put a disposable plastic tablecloth over your table and only let the unclean things touch that plastic tablecloth and not be able to touch your house. I wouldn't want you to put unclean things on your kitchen counter or on a plate or anything like that. You could go to the Dollar Tree and get a knife just for that circumstance, that you're cutting it apart. Probably it'd be wise to get a scalpel, but then you're going to have to clean it. So you can look in the scriptures and find out how to kosher something that has touched something that's unclean. So these are perfectly legitimate discussions to have, but you can protect your house against those unclean things. Or you can go online and watch the dissection, but I think your kids would learn more if they did it themselves. I think in science, it's also important to, just like in history, to take some field trips. Again, I recommend that in the summertime, you look ahead at some of the topics that are going to be discussed, and then you try to find out what the resources are in your state. What do you have available to you that you could go to? Sometimes in science, it's who do you know? Do you have someone in your local Sabbath fellowship that is involved in some kind of industry and they would be willing to give a field trip or demonstration to your students? That would be awesome. I would recommend that sometime over the course of your years that you're homeschooling, that you take a trip to the Creation Museum that's in northern Kentucky. The Creation Museum and the Ark Encounter are awesome. I cannot say enough good about them, except my only one thing is that they don't believe that Torah is for us today. But that 98%, I would say, of the museum is going to be accurate and dead on correct, unlike so many science museums you're going to take your kids to. So that might be something to save up your money and plan ahead for. It's just totally worth going to. Lastly, over the course of your years in science, as your children get older, you're going to want them to do a science project. Now, sometimes I like to let my kids do a simpler one in the middle school years and then a much more detailed one in the high school years. So to me, the benefits of an actual science project is that they are going to have to really research, and they're going to have to present what they learned in a written and oral way. So the written way, they're going to write a paper, and we have in our writing curriculum at Homeschooling Torah all about how to write a paper like that. And then they're also going to have to demonstrate, like get up in front of people and give a presentation and limit it to say 8 to 10 minutes. And they have to explain everything that they've learned. Now in their research, they're going to learn so many skills about what it's like to be a scientist. And by this I mean to really have to look up something that they don't know and have to tell about it. They're going to have to learn how to cite their sources, which these are such valuable skills no matter what industry or occupation your children go into someday. And they need to try to find some first-hand research or a first-hand way of demonstrating that what they think is going to happen will happen. Just like that whole scientific method we've been talking about, they need an opportunity to take something that they don't know themselves and hypothesize about it and then find out what happens and do it repeatedly. And this is going to make the perfect science project. So I would recommend that you make a science project at least once during the middle school years and at least once in high school. And if you like it more than that, do it every single year. And I would devote, say, 9 to 12 weeks of every school year to that. I like to do it in the spring because by that time we've got some science under our belt and we've got some writing under our belt and we've reviewed all of these things, and this kind of gives the capstone to their entire year of science. So Mom, if I'm saying all of these things, what do you do if you're too tired to get all of this done? How can you manage science if you've got a lot going on in your life and you're just not sure how to get to it all? I would recommend that you at least do vocabulary once a week and read your Bibles together. And then after that, you can use resources from your local library and from the internet to supplement your science. You don't have to have science discussions with your children every single day. So could you manage once or twice a week? That would be a lot more that would be a lot better. That way you can lay a good foundation before sending them off to the world and everything they're going to say about science. So that would be my idea. Otherwise, try to do science, a good firm discussion 3 times a week, and then 2 days to demonstrate and touch and research and look up. So that's again, a pretty good model. 3 days with Mom, 2 days on their own, coming back to Mom and reporting what they've learned. So I hope this helps. Science is important because it helps us to think logically and analyze everything from the eyes of a creator. I want my children to know there's a creator because in Romans 1 it says if they don't acknowledge the creator, they're going to start to worship the creation instead of the creator, and it leads them down a path towards absolute evil. So I think that the answer to evil in our world is to teach creation. And creation and science to me are the same. Everything that we do in science needs to acknowledge our creator, thank him and praise him for everything that he's done.